Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to be looking at trigonometry for your junior cert and more specifically Pythagoras Theorem. So as you can see in the meme here, Pythagoras Theorem is usually used when you have a right angle triangle with one side missing, and what Pythagoras Theorem does is it helps you find out what that side actually is. So just before we go straight into Pythagoras Theorem and like how it comes up in exams and how you're going to answer the questions, just to make sure you get your full marks, I'm just going to talk a little bit about what trigonometry actually means. So for trigonometry, the trig here is just short for triangles, and the onometry is like measure. So in general, what trigonometry is it's just measuring triangles. And for your junior cert, we can basically break that into two groups. So you've got your right angle triangles and then you've got your non-right angle triangles. So like your isosceles or your scalene triangles for this sort of section here. We're not going to look at these today. I'm going to do another video on those in a little while. Today what we're going to concentrate on is just our right angle triangles, and there's two sort of topics in maths that help you out with right angle triangles. It's Pythagoras Theorem, what we're going to have a look at today, and also sine, cos and tan, which are your trigonometric ratios. But we're not going to worry about those today. We're just going to worry about Pythagoras Theorem. In your log tables, page 16 is what we're going to be focused on. And if we just have a look at what part of page 16 in your log tables we're going to be focusing on, I suppose, it's the very last line there at the very end. It's that one there. And that tells us what Pythagoras Theorem actually is. Now, I've just put two lines up here at the start. The square and the hypotenuse of a right angle triangle is equal to, in area, to the sum of the squares on the other two sides. And it's used when you have two sides of a right angle triangle and are looking for the third. I'm just going to talk about that just a small bit more in a minute, but I'm just going to make my log tables here just a small bit bigger, just so we can see what's going on. Oh, I should have said it at the start, but any notes, any key notes about in this video that we go over, I will be putting it in the description, so no need to take any notes or anything. I'll put all the important stuff at the bottom. Okay, so if you look at page 16 of your log tables, like this is what you have here, and the top half of the page, you'll notice that the diagram that they're using is this triangle here. You'll notice that you're not told any of the angles in that triangle. You're not told that any of those are right angled triangles. So in regards like your exams, your three formula up here are for non-right angle triangles, but these three formula they don't come up on your junior cert course. These are leaving cert formula, so we're not going to worry about that or that. In this video and the next one, we're just going to worry about our right angle triangles and what we can do with those. You'll notice here that they've given us three other formulas: sine A, cos A and tan A. We're not going to use those today either. That'll be my next video. So all we're concentrating on today is this diagram here and this formula. And rather than do my notes here, I'm going to, I suppose, just in really simple terms, I'm going to put out what Pythagoras Theorem actually is, what a hypotenuse is, what a right angle is, and we just make sure we have our head screwed on before we have a look at exam questions. So Pythagoras Theorem works with right angle triangles. Right angle triangle, and I'll draw one as best as I can here, is, funnily enough, one with a right angle. Now a right angle in your exam papers is often denoted by a little box there, and a right angle is 90 degrees, in case you didn't know that. So it makes an L shape, like a vertical line and a horizontal line. So once you have distinguished that you have a right angle triangle in your question, what your Pythagoras Theorem does is it helps you fill in pieces of information that you don't necessarily have already. So the first thing you're going to do is you're going to decide, well, which side of your right angle triangle is the longest side. And oftentimes with your right angle triangles, it's really easy to see that just by looking at it. But there is a foolproof way of knowing which side is your longest side in any right angle triangle. It's going to be the one opposite your 90 degrees. So your 90 degrees will be given in your question. And the side opposite that is going to be your longest side. So a handy way of remembering that is that your biggest angle is always going to be opposite your biggest side in not only right angle triangles, but any triangle that you have. And your longest side has a particular name. It's called the hypotenuse. H-Y-P-O-T. Now, I'm just going to check my spelling of that. I have it written down back here. E-N-U-S-E. Hypot. E-N-U-S-A. And the hypotenuse is just a fancy way of saying your longest side. So, seeing as I have that back in my other slide there, I'm just going to rub that out. But just to show you, that was just to show you that the longest side is called your hypotenuse. And I will put that in the description at the very end. Now, in your log tables, that's labeled as C. And we'll come back to that in a minute. Your labeling is very important of this in this type of triangle. And your other two sides were labeled A and B. And I'll just go back here. I've basically just done the same thing as this diagram here. Now you'll notice that for my formula, it says C squared is equal to A squared plus B squared. So C squared is equal to A squared plus B squared. And this is the reason that I've said that the labeling your C is so important. It's because you'll notice that your C squared, your biggest side, is being squared and it's over on the left-hand side of your equal sign. But more importantly than that, it's on its own. So what we're saying here is that if you have a right angle triangle, the square on the hypotenuse, so the square on the biggest side, is going to be equal to one of your smaller sides squared plus the other one squared. So the most popular triangle that has this sort of property is this one here, 3, 4, 5. So this triangle here has that property. So, and just to show you that, if we were to fill our numbers here into our formula that we have here, what we would get is, well, my C squared, if I label this triangle first, my 5 is going to be my C, my 3 is going to be my A, and my 4 is going to be my B. If I was to substitute my numbers now into my formula, I would get that 5 squared is equal to 3 squared plus 4 squared. And if I was to simplify that, or if I was to do that out, 5 squared is 25, 3 squared is 9, and 4 squared is 16. If I was to, I suppose, do my last sum there, the last thing that I can tidy up there, I get that 25 is equal to 25. And you might say, oh, well, that's obvious. What that tells us is that seen as these three numbers, the 3, the 4, and the 5, seen as those fit into Pythagoras' theorem, and when I do fit them in, like my left-hand side equals to my right-hand side, that tells me that this triangle up here is a right angle triangle. So the first thing you've sort of learned there is, if you have three numbers that fit into Pythagoras' theorem, and when you tidy it up at the very, very end, you get one side is equal to another, then that means you can say that the triangle up above is a right angle triangle. And there's loads more numbers that fit into Pythagoras' theorem. If you have three numbers that fit in, they're called Pythagorean triples. So 3, 4, 5 is the most common, or sorry, not the most common, but the most popular, I suppose, the most famous Pythagorean triple. But 5, 12 and 13 is also 1, and there's loads more of them as well. So the first thing about Pythagoras' theorem, and I'll just gloss over this at the end as well, is that if you have a triangle and if you're wondering whether it is right angled or not, then if your sides fit into Pythagoras' theorem, you have proved that it is right angled. Okay. There's two other ways that this question could be asked, and that's covered on this exam question here. So 2014 question 13 on your paper 1. There was an I part and an II part that I've taken out, and they're sort of asking a different variation of the question that we were just after doing. So they say that in this diagram here, you have to find out what x is. And you might think, well, okay, I'm told that it's right angled. Oh, that's another, I know in my diagram over there I've done a little square, but a right angle can be identified by a little L shape as well. So we know that this is a right angled triangle because it tells us, but the question is now asking us to calculate the value of x. So seeing as it's a right angled triangle, and seeing as we're just working with our sides here, we're not given any angles. You'll notice that for Pythagoras' theorem, we're not dealing with any angles. We're not dealing with like this down here. We're not dealing with this here. We're given that it's a right angled triangle, but like it has to be a right angled triangle for Pythagoras' theorem to work. So we're not dealing with any angles. We're just dealing with our sides. So if I write down what Pythagoras' theorem actually is, it might be able to help us out to find out what x actually is. So if I write down that my c squared is equal to my a squared plus b squared, that's the first line of my Pythagoras' theorem. But I have to sort of convert my x, my 3, and my 3 here into like a, b, and c. So in other words, I've got to label my triangle over on the right hand side here before I can use Pythagoras' theorem. So just remember, that's where your labeling comes in. It's very, very important. You have to decide, well, what's your hypotenuse? Your hypotenuse is going to be opposite your right angle, so it's there. So that's going to be your c. And I'll just take this away just so I'm as clear as possible. Your longest side here is your c. Your two shorter sides, now it turns out in this triangle, your two sides are actually the same, but it makes no odds. They're shorter than your hypotenuse, and that's all that matters. So I'm going to label this one A and this one B. It doesn't matter which of the two shorter sides that you label A and B, because you'll be squaring them and adding them together anyways. So it doesn't matter what order you do the A and the B. The C is the most important, and I can't stress that enough. So once you have your A, your B, and your C labeled, what you're going to do is you're going to take your information from your picture here and you're going to put it into your formula. Now, I am aware that I've just sort of given you a formula and I've given you sort of like a right angle triangle, and I've said here, when you see a right angle triangle, use your formula. You do have to prove Pythagoras' theorem, why it works for each right angle triangle for your junior cert, and I'll go on to that in a later video on why it actually works, why it works with every single one. And I also have a video that I'm going to link you in the description below, just a demonstration about showing how it works. But this video is just about, I suppose, concentrating on exam style questions. Okay, back to the question we were substituting in. My c is x, so I'm going to have x squared is equal to my a squared, which is 3 squared, plus b squared, which is 3 squared. So when I simplify that, I'm going to get x squared is equal to 3 squared is 9, plus 3 squared is 9. I'm going to get x squared is equal to 18. And then if I get the square root of both sides, if you put this into your calculator, like x squared, if you're squaring something, and just so we're completely clear on what we're doing, if we're squaring, if we add together two numbers. The opposite operation of addition is subtraction. The opposite operation of multiplication is division. If you're squaring something, the opposite operation is to get the square root of it. So in order to get rid of the square root here, what we're going to do is, I'll just show you my workings out here because I'm not sure it's completely clear sometimes. If I get the square root of that side and the square root of this side, if you look at the left hand side here, I've got x squared and then I'm getting the square root of that. So the squared here and the square root, they work against each other. And all you're going to be left with is x. If you put root 18 into your calculator, you're going to get 3 root 2. And if we just look back up at our question, it says give your answer in surd form. Surd form means they're expecting a square root to be in your answer. So right now, that's absolutely fine. That's getting you your full marks. If it had said to give your answer in decimal form, you would have used your calculator. You would have gotten 3 root 2 on your calculator. If you press equals again on that, or if you press your change to decimal form button, you would have gotten 4.24. So, like, both of these are correct answers, but in relation to the question, just be careful. They want your answer in surd form. So right now, that's your question done. You found out what x is. Using Pythagoras Theorem, you'll notice that there was one side that you didn't know, there was 2 sides that you did know, and seeing as Pythagoras Theorem was based on 3 sides of a triangle, of a right angle triangle to be more specific, seeing as you didn't have one of those, by substituting in and working it out, you were able to find that last piece. Your question 13 part II was very similar, except this time you weren't looking for your hypotenuse, you weren't looking for your x, you were looking for one of the smaller sides. So we're going to come at this question the exact same way as the last one, except we just got to be careful with our labeling and our substituting in. So I'm going to start from the start. I've realized that this is a right angle triangle. I've realized that I'm looking for one of the sides that I don't have. So I'm going to say c squared is equal to a squared plus b squared. Now, our labeling comes into play. Our longest side here is the 3. So 3 is going to be my c. And my 1 and my y, they're going to be a and b. So I'm going to label this a and this b. Again, your 1 and your y being the smaller sides, I could have labeled my y as a and my 1 as b, but it's going to make no difference in regards to the rest of your question. So c squared is equal to a squared plus b squared. Let's put in the information that we're given in our question. We're going to have the 3 squared is equal to a squared, which is 1 squared, plus y squared. Now be very, very careful there. Like, once you get to here, it's just your algebra being tested from then on. But what some people do is, and it breaks my heart, they'd say, oh, like, I've gotten a right angle triangle, I've gotten my 3, my 1 and my y, I'm going to say that y squared is equal to 3 squared plus 1 squared. But y here, it's not your hypotenuse. It's not your biggest side, so don't put it on one side of your equal sign on its own. Your biggest side has to go there. So this right here would be wrong. And you would end up getting, even though like you have Pythagoras Theorem in and the whole lot, and like even if everything was perfect after that, you would lose the majority of your marks there just for a small little mistake. So just be careful there. 3 squared is going to be 9, is equal to 1 squared. 1 squared is 1 plus y squared. Now I want to find out what y is, because that's what the question is asking me. So I'm going to take 1 away from both sides, and I'm going to end up with 8 is equal to y squared. I'm going to get the square root of both sides, and I'll just go over here, and on my calculator I'm going to say square root of 8 is equal to 2 root 2 is equal to y. I'm just going to check to see, well, how do they want my answer? Do they want it in surd form? And yes, they do. Give your answer in surd form. If they didn't want my answer in surd form, or if you had gone straight to your decimals, you would have gotten 2.828 is equal to y. So if they want it in surd form, leave it like that and you'll get your full marks. If they want it in decimal form, there we go at the bottom. So just to show you the marking scheme, now seeing as this was 2014, the marking scheme isn't as complete. It doesn't give us as much information as previous years, but there was 5 marks going for each of those questions. And if you didn't get your 5 marks, you were either getting 3, 2, or nothing. So you'll notice that for the first one here, they're working out here is they've used a sort of simplified form of Pythagoras Theorem, but we're not going to have a look at that because it's just one other thing that people can get a bit confused on. But you'll see the most important part here is they got their answer 3 root 2 at the end. They've done it another way over here with sine 45, but we're not going to have a look at that just yet because we haven't had a look at sine, cos, or tan just yet. That's my next video. You'll notice for part II, they've gotten their 2 root 2 as well, which is exactly what we got. So in regards to questions, 5 marks and 5 marks. Just in relation to that, 5 and 5, I suppose that's like 5 marks is nearly the lowest you can get for a question. If you had that like in previous years, or if that exact question came up again in previous years, you could be looking at 15 marks for the whole 2 questions. Like that was, in my mind, that was low enough marks for the 2 questions. So just to be aware of that. Right. I think that's all I wanted to go through. Your key points. So use Pythagoras Theorem when you have 2 sides in a right angle triangle and you're looking for the 3rd side. Label your hypotenuse as C in your formula. That's probably the most important. Substitute in your formula from your question. Tidy it up. Find out what X or Y is or whatever the question is asking you. Pythagoras Theorem can also help you prove that a triangle is right angled. So if you're given 3 sides in a right angle in a triangle and you're asked to say, well, is that actually right angled? So let's say if you were saying you had a triangle here, and I'm not going to label this angle here, I'm not going to label that as a right angle, but if you had, like, let's say 5, 6, and 8, and you were asked to say, well, is that right angled or not? Well, let's see. I'm going to have c squared is equal to a squared plus b squared. If that triangle is right angled, my numbers here should fit into this. So my biggest side is going to be 8, because if my right angle does exist, it is going to be there. It's going to be opposite my biggest side. So 8 squared is equal to 5 squared plus 6 squared. Let's see if this works out. 8 squared is 64, 5 squared is 25, 6 squared is 36. I'm just going to go up here. 64 is equal to 25 plus 36. 25 plus 6 is equal to 61. Now you know that 64 is not equal to 61. They're not the same number. So if those two are not equal, then that means that each of these lines here is incorrect or doesn't equate to each other. So that means if those 2 numbers are not the same, the triangle up here is not right angled. So just going back over that first point that I made, and just one last thing just to be clear of, Pythagoras Theorem can be hidden in the question. The diagonal of a rectangle, for example, so if you have a rectangle and you're asked to find the diagonal of it, it's not completely obvious, first of all, that you're actually dealing with a right angled triangle just there. So once you have that right angled triangle, and if you have like this side and this side, you will know, you'll be able to use Pythagoras Theorem to get your hypotenuse. So just be careful, your right angle can be hidden in questions as well. Or in the shadow of a building. They're fond of like drawing a building here, drawing the sun up here somewhere, the shadow comes down, and all of a sudden, and the ground is here obviously, that's a right angle, and all of a sudden your right angle triangle is there in your question, but sometimes people they can't see that or they're not aware of that, so hoping that doesn't happen to you guys. Okay, I'm going to put, just to wrap up, I'm going to put the key points below. I'm going to put a link to a video on, it's from QI, which is hosted by Stephen Fry, I think, at the moment, about Pythagoras Theorem, how it works. There's a nice little animation in that. Also, I'm going to put in a clip from Piers Morgan's Good Morning Show, I think it was called, when he made a mess of Pythagoras' theorem and pi, the number pi. So nothing to do with your junior cert, but it was just funny, him mixing those two up. If there's anything I've forgotten, I'll put it in the description. But for now, that's more or less all you need for Pythagoras' theorem for your junior cert. Alright, thanks for watching.